So what is a simple pendulum?
A simple pendulum is defined as a small heavy body suspended by a light inextensible
Inextensible string. This is the thread. It is inextensible. We have one that can stretch. This one cannot stretch. This is thread. This is the pendulum ball. Is the metal. What you call it? Heavy metal. So while it is suspended, this is the rotor stand holding it firmly. Is that clear? Is that clear? So the simple pendulum carry out oscillatory motion. Carry out what? Oscillatory motion. Look at it. Once you displace it from this rest position, you take a little amplitude, a very small amplitude, exactly a small angle of exactly that we use a very small angle to displace it and allow it to move freely. As it's moving, look at it, to fro, to fro. That to and fro movement is what we call one oscillation. Exactly one what? Oscillation. He move as he move to and fro. That is one oscillation. To and fro, one oscillation. The time taken for the pendulum ball to complete one oscillation is called period. It's called what? Period, or the periodic time. It is given the symbol capital T. Exactly. It's given the word capital T. We can use this simple pendulum motion to determine the acceleration due to gravity, small letter g. Is that clear? You can use it. How do you use it? You will measure the length. You will measure the length of the thread of the pendulum bulb. Is that clear? From the point of release where it can be displaced to the center of the gravity of the bulb. Is that clear? You take the length. The one you are going to do for me today, you are going to take the length to be 100. The first length will be what? 100. So you are going to write it. The length of pendulum bulb is 100. 100.00. Then you are going to determine the time for 20 oscillation. That means you take your stopwatch. Once you take your stopwatch, you release it. Let me release this way. You see it now. To fro one. So if you start counting from this place now, as you come back, that is one, two, I see now three. You get to 20, you're going to stop your stopwatch and look at the time for 20 oscillation. That is for 100 centimeter length of thread. You're still going to repeat it for 90 centimeter length of thread, 80, 70, and 60. Is that clear? In each case, determine the time for 20 oscillation. So I put T1, T2. Why? Maybe the first time you might not be accurate. When you say start, you might not press it on time. You might not stop it on time. So you need to do it like up to 2 or 3 times to get the average time. Are you with me? After you get the average time, which is T2, T1 plus T2 divided by 2, you will now get the period of oscillation, the periodic time, which is the period. So the period T will be equal to T, which is what you have here, all over 20 in seconds. Are you seeing that? Then you now take the square of until you get here. After you have done that, you're going to plot a graph of L on the vertical axis and T square on the horizontal axis. So you will use this formula. You will now evaluate, determine the slope of the graph. Call the slope of the graph S. Exactly. So after you already the S, to now get the value of G, it is 4 pi square times the slope of this graph. But ADB you plot the graph T square on the vertical axis and L on the horizontal axis. To get your G to be 4 pi square over S divided by S, the slope. Is that clear? Is that clear? Whatever you get, you will now convert it because here is in centimeter. You will now divide it by 100 to get your answer in meter per square second. And that will be the acceleration due to gravity or free fall. Is that clear for this particular region that we are? Are we together? So let's try that now. So take your apparatus and try that.